In this third lesson, in the quadrilateral unit, you're going to do two things with the coordinate plane. First, you're going to identify polygons by plotting the points, and then you are going to determine the type of quadrilateral. So first, let's identify the polygon. Let's plot the points. Here are the vertices. So we're going to do -5, 2, which is -5 up 2 right there. Then we're going to do -5, 7, 2, 3, 1, 2, 3, and 2, -2. So first, plot the points. Then, connect the dots. I'll be as straight as I can. This will be much neater in Alex. Alrighty, so you are going to determine, is this a triangle? No, it has 4 sides. So we know it has 4 sides. Is it a rectangle? Well, does it have 90-degree angles? No, it does not. Is it a parallelogram? Well, let's look at it. Do opposite sides intersect? They do not. And if you count the units, which I'm going to do in yellow, 1, 2, 3, 4, 5, that's 5 units. 1, 2, 3, 4, that's 5 units. It is a parallelogram. You might get none of these, you might get parallelogram, but that's what we do. We are identifying the polygon. Now let's do the next one. It says, you try, I want you to try. If you're doing this on paper, plot the points. If you're doing it on the screen, see if you can do it with the cursor. -4, 7, -4, 0, -7, 0, and -7, 7. Connect my dots. There we go. Is this a square? Well, obviously not, because you can clearly see that all 4 sides are not congruent. Is it a triangle? Nope, it has 4 sides. Is it a rectangle? You can see that the angles of intersection, and again, I'll do them in yellow, are right angles. You can easily see that. So yes, it's a rectangle. That wasn't hard. Here, we're going to prove quadrilaterals are parallelograms. Now, you have to remember some of the requirements for a parallelogram. Okay, and I'm going to put them up here. Opposite sides are parallel. Those 2 lines are parallel signs. And opposite sides are congruent. Those are 2 of the categories. On a coordinate plane, we know nothing about angles. I mean, we can identify a right angle, but we can't identify anything else. So here we go. We'll do the slope formula and the distance formula. What? Yes. This is something we covered in Unit 6 in Algebra 1. I'm going to write this in red. A perpendicular slope is negative reciprocal, and a parallel slope is the same. So what you're going to be doing is determining probably the slope, sometimes the slope of the lines identified, the segments identified, excuse me, and sometimes you're going to use the distance formula to find the length of the sides identified. It depends on what the question asks. So here, we're looking for the length of JM. You can see that JM is a diagonal. So you can do 2 things. You can use the Pythagorean theorem which actually is pretty quick. Or you can use the distance formula. You're going to get the same answer. So I'm going to mark it up. Okay, I'm going to draw my little right triangle. And let's see, this side is 2. This side is 1, 2, 3, 4, 5. So I'm going to say, for the length of JM, 5 squared plus 2 squared equals JM squared. 25 plus 4 equals JM squared. Square root of 29 is JM. Leave it as the square root. Do not go decimal. Okay? Do not go decimal. Now let's find the slope of JM. I'm going to do that. I'll do that in blue also. JM, there are my coordinate points. There's my slope formula. So I'm going to go 1 minus 3, let's see, x1, y1, x2, y2. Everything I'm doing is in blue. 1 minus 3 over 4 minus negative 1 gives me negative 2 over 5. So the slope is negative 2 over 5. And again, we leave it like that. Now we're going to find the length of KL. I'm going to do that in green. I'm going to use the Pythagorean theorem because I just think it's simpler. So draw my little right triangle again. This is 2. This is 1, 2, 3, 4, 5. Just double checking. So again, 5 squared plus 2 squared equals KL squared. 25 plus 4 equals KL squared. Square root of 29 equals KL. Leaving it as the exact answer, leaving it under the radical. Let's look at the slope of KL. x1, y1, x2, y2. And I'm going to do that down here, down below the red. So negative 7 minus negative 5 over 1 minus negative 4 gives me negative 2 over 5. So what do we have? We have the lengths are congruent and the slopes are the same, which means the lines are parallel. Now we're going to make a choice from our options. What can we conclude? You have to read them carefully. Let's see, it's a parallelogram because it has one pair of opposite sides that are parallel, even though those sides are not congruent. Well, that's not true. JM and KL are congruent. We know they're parallel because they have the same slope. They're also congruent. Let's see the second one. It's a parallelogram because it has one pair of opposite sides that are both congruent and parallel. That one's right. We can stop right there, but I want to go through the others. Let's see, it's a parallelogram, one pair of opposite sides that are congruent even though those sides are not parallel. Well, if you look at the first and the third choices, they are incorrect because they use what they say is a parallelogram is incorrect. A parallelogram has opposite sides that are parallel and congruent. So that's why you know it is a parallelogram. We've got parallel sides, and it cannot be determined. Well, that's not true either. So on this, I recommend the Pythagorean theorem if you're comfortable with it to find the length. If you are not comfortable with it and you use the distance formula, you're going to get the same answer, and that's fine. Use the distance formula. The length, that's to find the length. The slope, use the slope formula. That information is going to determine whether the quadrilateral is a parallelogram or not. Do not try to do this too fast. Be very methodical. And that wraps up Unit 4.